This tutorial is for 2nd grade, Module 2, Lesson 6. In this lesson, we will use centimeter rulers to measure lines and then use those measurements to make comparisons between the lines. For example, if I were to measure line A, we would find that it is 14 centimeters long, and line B is 5 centimeters long. The question says line A is about blank centimeters longer than line B. The key here is to read the question carefully, so we're looking to see how much longer line A is compared to line B. A couple of different ways I can come up with that answer. I could start at 5 and count on from 5 to get to 14, and that would tell me how much longer A is than B. Or I can look at this as a subtraction problem, the difference between the two measurements. 14 minus 5 equals 9. So line A is about 9 centimeters longer than line B. When we measure line C, we find that it is about 8 centimeters long, and line D is also about 8 centimeters long. The question says line C is about blank centimeters shorter than line D. Well, if line C is 8 centimeters long and line D is 8 centimeters long, they're actually the same length. Line C might look like it's shorter because line D sticks off farther across the page than line C. But the key here is that line C starts at a different point. So if you were going to compare these lines visually, you would want to line both of them up, one on top of the other. So that can be a little deceiving for students if they don't pay close attention to where the lines start. The key here is that line C is 8 centimeters and line D is 8 centimeters. So line C would be 0 centimeters shorter than line D. Here we have 3 different lines to measure, and once again, these lines are not lined up directly one on top of the other. They all start in different points, so we need to rely on our measurements to answer the questions below. When we measure line E, we'll find that it is about 3 centimeters long, line F is about 6 centimeters, and line G is about 7 centimeters long. The first question says lines E, F, and G are about blank centimeters combined. So I want the total distance. I just need to add the 3 numbers. 3 plus 7 plus 6. I'm going to start by making a combination of 10. My 3 plus 7 is 10 plus 6 equals 16. So combined, all 3 lines are 16 centimeters long. The next question says line E is about blank centimeters shorter than line F. While line E was 3 centimeters, line F is 6 centimeters. So again, I could count on 3 plus blank would give me 6. Or I could turn this into a subtraction problem to find the difference between the two lines. 6 minus 3 equals blank. Either way, the correct answer would be 3. 3 plus 3 is 6. 6 minus 3 equals 3. So line E is 3 centimeters shorter than line F. Here it says line E is about blank centimeters shorter than line G. And again, line E is 3 centimeters and line G is 7 centimeters. We could use the same process here. I could start by counting on, since line E is 3 centimeters, then how many centimeters would I need to equal line G? Or turn it into a subtraction problem. 7 minus 3 would tell me how much shorter line E is compared to G. In this case, both answers would be 4 centimeters. The next problem says line G is about blank centimeters longer than line F. So line G is 7 centimeters. If I subtract the length of line F, which was 6 centimeters, that tells me that line G is 1 centimeter longer than line F. And this question says line F doubled is about blank centimeters longer than line G. So this is a two-part question. First, we have to double line F. Well, line F is 6 centimeters. 6 plus 6 equals 12. So I'm comparing the 12 centimeters to the length of line G. Line G is 7 centimeters. So 12 centimeters minus 7 centimeters equals 5 centimeters. So line F doubled is about 5 centimeters longer than line G. The last question says, Daniel measured the heights of some young trees in the orchard. How many more centimeters does each tree need to have a height of 1 meter? Well, in order to determine that, we have to remember that 1 meter is the same thing as 100 centimeters. In this case, I'm going to use a number line to help me figure out the answers. So I'm going to draw an open number line, and I can see I'm working within a range. Let's see, I have 90 centimeters, 85, 81. Let's start with 80 centimeters. And since we're going to the distance of 1 meter or 100 centimeters, I'll put that in as the end. Halfway would be 90 centimeters. Between 80 and 90, I would have 85 centimeters. Between 90 and 100, I would have 95 centimeters. So I'm going to use this open number line to answer the questions. For the first one, 90 centimeters plus blank would give me 1 meter or 100 centimeters. So if I'm at 90, I would have to do a hop of 10 centimeters to get to 1 complete meter or 100 centimeters. When I'm at 80 centimeters, I would have to do a hop of 10 to get me to 90, but another 10 to get me to 100. So 80 plus 20 would give me 100 centimeters or 1 meter. Starting at 85 on the number line, I would hop 5 to get me to 90, and then 10 more to get me to 100. So that is a total of 15 centimeters to reach 1 meter. If I'm at 81 centimeters, I can think of it this way. If I did a hop of 20, 20 would actually put me at 101 centimeters. Then I just have to hop backwards 1 to reach the 100 centimeter mark. So if I start by hopping 20 and I go backwards 1, that's the same thing as hopping 19 centimeters altogether. So 81 centimeters plus 19 centimeters would reach the 1 meter mark.